and I'm really happy to be with you tonight so that we can share some knowledge. Yeah. Okay, so I would like to ask before we move on to this module, that was module 3, what you guys have learned so far on that, because based on that, and we'll be proceeding to this endpoint vulnerability assessment. So someone can open their mic and share with me what they learned during their last session, which was on module 3. Anyone? Anyone? Please, are they allowed to speak? Do they have access to their mics?
Yes, they have access to their mics, but to make it organized, they can signify by raising up their digital hand. Then I'll
All right. All right.
give them the go ahead.
All right, that would be cool. Please help me learn and I'll help you learn. If I just start everything and just talk, I don't think that would be helpful. So I want to know what you know and I'll give you what I know. Yeah. Okay, Mr. Victor, you can go ahead.
Good evening, class. Good evening, instructors, Instructor Moni, and Instructor Vincent. Confirm you can hear me.
Yes, please, I can hear you.
Okay, so last class on threat intelligence was very informative. Instructor helped us to know what intelligence is. Um, the intelligence has something to do with knowledge. So to be good with threat intelligence, we have to know what's happening, what's currently happening, what's the trend, what the ongoing attack is, and so on. So if there is any current, recent, or perhaps planned cybersecurity incidents, it is good for us to know. So the doctor took us through organizations that that share information that will help us to be intelligent in discovering, analyzing, and responding to threats. Organizations like SANS, various parts of that organization, some arm of the organization uh, offer news on a very timely fashion about issues arising in the field of cyber security. Then that was I think I need to be very short. Newswire service, something like that. Then he
Okay.
took us through first. Got I mean,
Someone
this
else help me.
first was still under SANS, and that was forum of incident responders, incident response, and security threat. Something like that. I need to be very sure. I wasn't very good this week.
Well done, well done, well done.
It was something like that. And there were other organizations like IAC Square, which is um, information and double I and then double H and then double C. So that's ISC squared. Yeah. I will review my notes and then get that correctly. Then
All
he
right.
took us to another
All right.
that
That will be fine.
that was the CIAs, and he said CIAs stands for um cyber. What was that? I think that was CIAs was Center for Internet Security. I think that's it. Center for Internet Security, and that IS CIAs shares information to SLTT. SLTT. Um,
All right. I think
to
you've done well. Thank you. Thank you. I would like to have someone else to share with us what they've learned. I think you've really done well. It looks like you are teaching the whole class what you've learned again, and nobody can remember. So I want someone to prove me wrong by telling us what they remember, what they can remember, and what they've learned during the last session. That was the module 3. Anyone else can put up their hands to let me know, then I'll call them too. Go ahead. All right, you can go ahead. You can unmute yourself. Yeah.
Okay. I slept last week because I had a very hectic day. So I
All
only
right.
listened to the first part, which was the network intelligent communities, and we discussed about the organizations, that the network intelligence organizations and what they do. So we talked about SANS, MITRE, First, Security Newswire, and ISC Square, CIS. Then we were told that the center, CIS is the Center for Internet Security and is a focal point for cyber threats, prevention, protection, and so on. Then the ISC Square is the International Information System Security Certification Consult, which provides neutral education products and career services to people in so many countries of the world. Then the Security Newswire is a security news portal that aggregates the latest breaking news pertaining to alerts, exploits, and vulnerabilities. While First, which is a forum of incident response and security teams, is a security organization that brings together a variety of computer security incident response teams from government, commercial, and educational organizations to foster cooperation and coordination in information sharing, incident prevention, and rapid reaction. Then MITRE is MITRE Corporation maintains a list of common vulnerabilities and exposures, which is CVE, common vulnerabilities and exposures used by prominent security organizations. Then SANS, which is Sys Admin Audit Network Security Resources are largely free upon request, and they include the Internet Storm Center, News Bites, Risk, which is a weekly digest of newly discovered attack vectors. Then Flash Security Alerts, Reading Rooms. Then we were told that we have to keep abreast of the latest threats because threats are evolving as they are evolving even we also in cybersecurity, we have to be more alert and more proactive, and we have to look for ways in order to tackle this threat, and we must perform routine. It's not good to sleep during class.
It's okay. You've done well. I mean, it's not everybody
Okay.
that can remember what you've shared with us. I think that is really amazing and really appreciate. Yeah. So,
Yeah.
okay, I think we'll take it from there. It's really nice that some of you remember what you've been taught. That was last week, and I really appreciate that. So, as I said earlier, today our class is going to be really interactive. I will be telling you what I know, and you also will share what you know with me. I hope we are on the same page, right?
Yes.
Okay, thank you. So, right now we are let's go over our objectives for this module, which is for tonight. So, module 4, endpoint vulnerability assessment. What is this, and what are we going to talk about at the end of today's lesson? So, on your module 4, I believe everyone have access to the portal, which is the Cisco Network Academy platform. If you are here and you don't have access to the platform, please reach out to your course rep and let them help you out. So today, we're going to look at these topics: network and server profiling, common vulnerability scoring system, which is the CVSS, then secure device management. So we're going to explain the value of network and server profiling. Then we will also explain how the CVSS reports are used to describe security vulnerabilities. And also our last topic, which is secure device management. We're going to explain how secure device management techniques are used to protect data and assets. Are we on the same page? Let me see some emojis if we're all on the same page. Okay. So our first topic for tonight is network and server profiling. But before we move on, I would like you to tell me what you know about a network and a server, because I want to make sure that we are all on the same page and we understand these key terms before we go on with whatever we have on board. Because if you don't understand what a network is and what a server is, there's no way you're going to understand the topic for tonight. So anybody can raise up their hands and I'll call them. Okay, Mr. Victor, please kindly go ahead.
Okay, so a network is made up of network devices as well as okay, so network devices divided into two. We have end devices and we have end devices which are hosts. Host can either be a server or a client. In the case, if the host is a server, then it means that it provides services to other devices in a network.
Okay. Anyone else? What a server is or what a network is? Anyone else that can help us with? I think, Mr. Victor, you've really done well. Tonight, you are the king in the room. I'm only hoping no one come after you. So, please, anybody else? Okay, Mr. Peter, you can go ahead.
Good evening, everyone.
Yeah, evening.
Yeah. For me, my understanding of a network is a connection that is established for devices to communicate. When a connection is established between two devices, whether host or a server, that becomes a network. because network is all about interconnecting systems. So when systems are interconnected and their connection is established for effective communication, we can say that we have established a network. And a server is can be a device or instrument by which resources are being fetched from and be served to clients.
Okay, thank you. I think by these two amazing people that have given us the definition of a server and a network, I believe we all good and we understand. And if you don't understand, basically your day-to-day activities that you do with your devices, every device that you are able to use to access the internet, share files with your friends, your co-workers, and everybody around you, that is basically a network. If you want to dive deep to know how it works with their IP address and stuff, I think you have to do a research or take a deeper course in networking to understand this concept, how the internet works. And basically, when we talk about a server, as they explained earlier, I mean, if you want to get a file, if you want to share something, if you want something, those things in the internet are stored on a specific devices that we can get them, and these devices are referred to as servers. They serve us. So that is it. So all right, so let's jump right into our first topic, which is network and server profiling, as I said earlier. So let me know if you can all see my screen, because I don't want to be moving without anybody giving me the response that they can not see my screen. Are we all seeing what I'm sharing? All right. Thank you, Mr. Victor. So the first point when it comes to network profiling is to spot serious security incidents. We first have to understand what normal looks like on our network. This is where network and device profiling comes in. So we create a statistical baseline that acts as a reference point. Any unexplained deviation from this baseline could indicate a compromise. So basically, when it comes to network profiling, this is one of the things we have to do. And then now, this baseline has to be current. We can't use old data that doesn't reflect how the network runs today. A technique called the sliding window. This technique is anomaly detection that helps with this profiling. So it defines a specific window of time that's most representative of normal operation and drops out of data. So this process repeats to keep the baseline accurate. So for example, if you suddenly see high WAN, which is 1, like usage at 3 a.m., and that's not normal for your organization, it could indicate a data breach and data exfiltration. So basically, what we are saying is that if by the time you are using this, maybe let's say 3 a.m., and that's not a normal something, especially when you set your network configurations and you are not expecting a certain login at a time, and maybe let's say one employee just logging on your server and you get this log. This is something that we need to worry about, or you and your organization need to worry about. So we can use tools like NetFlow and Wireshark to build these profiles on normal traffic. And remember, organizations have different peak times. Think they like you have to think like day versus night or end of quarter. So baseline needs to be done over an extended period. I hope this mean? Okay, I can see some hands up. Mr. Peter, okay. Please, if you have any question, you can go ahead. Yes, you can go ahead.
No, sorry, it was my former hand that was raised.
Oh, okay, that's fine. It's absolutely fine. Okay. So I believe we can continue now. I said it was a mistake. So I hope we understand. Now, when we move on, I believe I'm not going too fast. Okay. So we can see the next slides, right? Okay, so what elements make up a good network profile? We look at a few key things, which is session duration, total true output, ports used, critical asset address space. So these 4 things that we mentioned are the things we look out for a good network profile. So when we take the session duration, this explains us how long does a data flow typically last. And when we look at total true output, how much data usually moves between a source and a destination. So when you come to networking, we have something we call source IP address and destination IP address. So all these key terms are from networking, that if you've ever tried to learn what networking is, you may have come across these terms. And also, when we look at the ports used, we have what TCP and UDP ports are normally open and accepting data. Malware loves to, use these unusual ports. So this is a great indicator. Basically, TCP and UDP are the models of networking. They are one aspect of it. Networking is not easy. To be honest, when I was taking that course, I was even stranded. I was like, yo, this is too logical. Why can't it be explained simply just like the normal day English that we speak? But it is what it is. The person who came up with this concept does not want to spare anyone. So I think you have to go extra hard to get this concept. So we move on to the critical assets address space. What are the IP addresses of our most essential systems and data? So another important metric is host-to-host traffic. Most clients' computers talk to servers, not to each other. Remember, a sudden spike in client-to-client traffic can be a major red flag that malware is spreading lately across the network. So finally, we also look for changes in user behavior, which we can get from AAA. And these are terms when it comes to server and websites. We have these terms. So server logs or a user profiling system like Cisco Identity Service Engine. So basically, when we talk about this, you are looking at logs that this system we've set up, we've configured, have captured. So user behaviors, as I told you, maybe your organization closed at 3 or 4 p.m. And let's say late in the night, someone log into a machine. If it is not an attacker who is trying to get access to this system, then who else? It might be someone from your organization who has given the credentials to another person, or the bad guys out there are doing it themselves. Whether it's through brute forcing, whether it's through social engineering attacks. There are a lot of attacks that conduct to get access to a system. So this is something that is things that are not good. And if you configure your system well, you'll be able to get all this information. You'll be getting alert when these things happens. Okay, so I believe we all understand what this means. So let's move to the next slide, which is self-profiling. So similar to network profiling, we also need to do server profiling. That was networking. Yeah, so we also need to do server profiling. So this establishes the accepted operating state for a specific server. So you can think of it as a security baseline for that single machine. So if you have a single machine, this is something you can do. So to build this profile, you have to understand the server, like your server's function. What is it supposed to be doing? Once you know that, you can define and document its parameters. So the key elements here include the listening ports, the login user, like users and accounts, the service account, and the software environment. So when we take the listening port, that is what TCP or UDP ports should be open. Logged in users and accounts. So who should be accessing this server and how? When it comes to the service account, what services are allowed to run? Then we can also look at and the softwares. So what tasks, processes, and applications are permitted to run on this server? I hope, or I believe by now, each and everyone in this room knows how to access their task manager on their Windows machine to know what specific applications and tasks their computing device are running. Because when it comes to maybe detecting malwares and stuff, this is some of the places you can monitor. And if you are good at it, you'll be able to realize that, okay, this is unusual. This application that is running in my background is unusual. It's not something that happens frequently. Then you get even, because now we live in a world where hackers and malware creators can use AI to create a very powerful script, malware script, that when they are running in your background, you wouldn't be able to get alerts. They bypass the method of alert. This is where we are right now, because AI is so powerful that they can do this within a twinkle of an eye. So it is always best for you yourself to go to your task manager, and should be able to recognize processes and applications that are not supposed to run. So for me, what I normally do is when I start my operating system or when I install things fresh, especially applications, I go to my task manager and I disable all applications. That's when I turn on my machine, they start to run automatically. I don't need it. I can run it when I want to use it. And this saves my battery. It saves me from any malware attack, because the viruses are in these applications. So I think by now everybody should know about this task manager application in your OS. So you should check it out. If you don't know, you need to check it out. It will really help you. So let's move on to our network anomaly detection. So once we have our baselines, we can move to the network anomaly detection. So network behavior is complex. That one you need to know. It is really, really complex, especially in the age of AI. Everybody is happy about AI, but behind the scene, AI can kill a lot. I mean a lot. So network behavior is complex, described by huge amounts of device, unstructured data, packet flows, packet features, and a whole lot. from many sources. So one way you and I can analyze all this is by using the big data analytics. Someone will ask, so this is known as network behavior analysis, or NBA. Please, those of you who love the NBA basketball game, that's not what we're talking about. Please, that's not what we're talking about right here. So the NBA uses a sophisticated statistical and machine learning techniques to compare our normal baseline with what's happening on the network right now. So this is an application that have been built to help you. I mean, it's really hard sometimes for human beings to figure things out themselves. So with the help of programmers, they can help us automate these things with softwares. And this is one solution. So significant deviations can be indicators of compromise. So for example, anomaly detection is great at recognizing the scanning behavior of a worm as it tries to find other vulnerability hosts on the network. That is something that these applications are really, really good at, that sometimes human beings miss these things. It's not easy because these applications communicate with the computing system. I mean, when you open your laptop, the motherboard, if your lecturer or nobody explains to you that there are buses or lines of buses, that is where information data passes. You never have any idea. And for you to even understand how the CPU alone works, I won't lie to you, it takes a lot. So sometimes you, the human being, will miss things, but applications are meant or are programmed to communicate with these buses and stuff. So they help the work to be more easy, if I may say. At this point, let me know if we are on the same page or anybody is confused and need clarification before we move on. And if anyone also have anything to share with us, that would be really helpful. If I'm moving too fast, please let me know. Come again. Come again. Okay. I believe no one want to talk, so let's continue. So let's look at a simple example. So the figure you can see below shows a basic algorithm designed to detect an unusual condition at an enterprise border routers. So when you hear the term algorithm, it's basically an instructions. So a process, if maybe you want to, let me use this as a real life example. If you want to prepare food, you have to get your ingredients. When you get your ingredients, let's say rice, you don't just start putting the rice on fire and doing the things, then you get rice. You have to follow a certain procedure. You get your ingredients, you get your water, you get your source of fire, whether it's a gas, it's a charcoal or whatever, you light it. Yes, so it is basically a procedure. You can't jump from this step. So basically computer applications also follow this process. So that is what we call algorithms. So as I said, they are designed to detect an unusual conditions at an enterprise border because you cannot do it. So these applications can do it much faster. So let's say an analyst, that will be you, hopefully, if you are able to finish this course successfully. Set these values. So we have X is to 5, Y is to 100, then Z to 30, and let's say N to 500. So here is how to interpret this algorithm. Every 5 minutes, which is X, get a simplified, hello? Can I move on? Can I move on? Okay. It looks like Faith want to talk, but you're not that audible. Okay, let's move on. So let me try again so that you get it. So here's how we are going to interpret this example that we're going to work with. So
Sorry,
let's
Instructor
say,
Vincent. Pardon my
yes, ma'am.
interruption.
Yes,
Please,
ma'am.
if you are not our instructor tonight, mute your microphone. And please don't let me repeat it. By now, you know how we do it, right? We don't have to beg you to mute your microphone. It's just what courtesy demands. If you have any contribution, you raise up your digital hand. You don't have to. Do you notice you are interrupting his flow? That's not nice. Please be kind. Mute your microphone. We don't have to tell you that. If I hear again that you interrupt him, I will remove you from the call. Please don't push me to do that. Sorry about it, please.
It's okay, ma'am. Okay, so sorry, forgive me for those of us who don't like math like that. This is not something you have to run away from. I mean, everybody have heard find X, find Y, and find Z. So basically, this is our normal math. This is not anything we have to run away from. This is not calculus. So I just want to make this simple so that we all understand. So I want to start again so everybody follows. So here is how I want to interpret this algorithm that I mentioned earlier with the values X is equal to 5, Y is equal to 100, Z is equal to 30, then N is equal to 500. So if I am to interpret this algorithm, I will say every 5 minutes, which is X, get a sampling of 1 out of 100, that is a position 100, which is Y, of the flows during the second of 30, which is Z. So the seconds is 30. That was represented with Z. So if the if statement, those of you who have done programming before, you know conditions, what the conditions means. So if the number of flows is greater than 500, which is N in this case, generate an alarm. If not, do nothing. So this is a condition. This is an algorithm. We are following a procedure. First, we said in every 5 minutes, which is X, we get a sampling of 100, which is Y, of during every 30 seconds. And if the number of flows is greater than 500, which is N, then we generate an alarm. If not, we shouldn't, the application should not generate anything. So this is one algorithm that help us automate. And these applications mostly runs in the background. They are part of the processes or daemon. Daemon is an application or a process that runs in the background. You don't see them as your physical applications that you are running. So those daemons can be found in your task manager. That is where you can monitor those processes. I hope we're good. So this is a very simple example of using a traffic profile to spot a potential data loss event. So this is different from the rule-based detection, which analyzes decoded packets for known predefined attack patterns. I hope we're good. So this should help you understand what, so as you can see in the diagram, this should help you to understand what an algorithm is. And that is how our programmers build our applications for us. Okay, so let's move on to the next slide, which is network vulnerability testing. Oh, this term might sound obvious, but I'll ask you, I want to know, what are your thoughts, or what do you know when we mention the term network vulnerability? I will be glad if any one of you can help me understand or help the whole class to understand what network vulnerability is. Since we know what networking means, I believe we should know what vulnerability also means. So when we combine these two terms, we should be able to define. So can someone help me define what a network vulnerability is? Anyone can just put up your hands and they will be called. Anybody? Or you want me to mention names? If you want me to mention names too, that will be fine. I can help you with that. Anybody? I don't want you to be sleeping. So anybody at all can help us what network vulnerability means. You don't just have to be doing things like Baba, you and poor, you go and write your exams and you pass, that's all. No, cybersecurity doesn't work that way, because if you don't know, you don't know, and you mess up systems. You have to have it at the finger. So someone has it. Okay. Okay. I think I like that. That definition in the comment section is really good. Anybody else? Okay. Sorry, you don't have your name. It's only your number that is on it. I think maybe it's a Ghana number or something. You can go ahead. Please unmute and tell us what you think network vulnerability is. I can't mention your name because you don't have your name on your profile. Yes.
Good afternoon, class. Good evening,
evening.
sorry. Okay, I'm just gonna explain a brief on network vulnerability.
All right.
Okay, so as per
Excuse
my
me.
understanding, hello?
Before going ahead, can we know you? We can't see your name, just your number. So can you introduce yourself? Let's know you. And please always
Okay.
change your number so we can relate with you as a person. Thank you.
Oh, sorry for that, ma. My name is Panashe Mnyoro from Zimbabwe. Hello? Hello?
Yes, I can hear you. Please, you can go ahead.
Okay, so I'm saying I'm Panashe Mnyoro from Zimbabwe, a computer science student.
All right.
Happy to be within class today. So I'm gonna continue. I think network vulnerability refers to weaknesses or the flaws in a computer network design, which means these are maybe the loopholes that one can use to penetrate into a network. That's my basic understanding of the network vulnerability.
Wow, amazing. Can we give him emojis in the comment section, because he has really done well. He has really done well. Okay, so basically the goal, and you as a cybersecurity professional, if we want to go the ethical way, then we might ask ourselves, what is the job of us? What are we going to do? So basically, if a company or an organization hires you, they want you to follow scopes, to be able to find weaknesses in their computing system, in their network, in their infrastructure. All banks, all companies that deals with computers, they all use network. And this network have weaknesses, have loopholes that an attacker, the bad guys out there, can use. And these weaknesses can be a port that is open. So let's take a port as a window of your house. So if you have your doors locked, but you have a window open, that's like a vulnerability in your house. The thief will not pass the front door again. They can use that window to enter your house. So the ports that are open, ports that are not supposed to be open, let me say it that way, you have to close it, but you decide to open it up because you want fresh air. Yes, cool, no problem. That is a vulnerability or a weakness in your house that people can pass there. Especially when you look at people who build walls around their houses, fences, and maybe some of the walls are short, others too, they have like they have places that you can use to get access to the houses. Those are vulnerabilities to their home. So when it comes to networking, it's the same thing. Things that you might take it as cool might be a very big issue in your network, and an attacker can use that against you. I hope we understand. That was just to add up to what he explained earlier. Okay, so let's move on to what we were saying earlier. So organizations have to connect to public networks and provide services, which opens them up to attack. I mean, it happens because new vulnerabilities are created all the time. Periodic security testing is essential. So because let's use the bank. This bank is running 24 service. It's always good for them to have a pen tester or an ethical hacker to find these weak points and report to them for them to fix it before the bad guys do. It's really, really essential for them to have this pen testing or network vulnerability testing done. If not, you know what happens. And you and our money in the bank will be taken, and the bank will come and tell us stories. We don't want to hear any stories. So always the bank makes sure that these testings happens so that they fix all vulnerabilities. And some of the vulnerabilities can be application update. Those of you who don't like updating your Windows because it's going to take a whole lot of internet or bandwidth to do that, please sacrifice and update your applications periodically. When they are updates, do them. As I'm speaking to you right now, Windows 11, they have the 2025 H2 version available. There was a vulnerability when they brought that out, and they have to fix it. So if you're a user and you are not up to date, those vulnerabilities that were found in the 22 H2 and the rest, you are vulnerable to attacks. So please don't take it as a joke. You are a cybersecurity professional. Let that name on you shows your actions. It will be really sad if someone who calls themselves like a cybersecurity professional gets hacked. I mean, it is really funny. If I were to spot one of you that has been compromised, I'll just laugh at you. I'll be like, you were just going through the slides just to get the mark. You were not doing the actual practice. If you don't want to be a victim, just follow the guide. It's really hard, but you have to do it. Okay, so let's define the three key terms when it comes to network vulnerability testing. We have risk analysis, we have vulnerability assessment, then we have penetration testing. So when we take the risk analysis, basically in cybersecurity, we have some people, we call them the GRC, governance, risk and compliance. This is a job title in the cybersecurity aspect as well. So these people mostly deals with the assessment, risk management and assessment and risk analysis. So this is where analysts evaluate the risk posed by vulnerabilities to their specific organization. So it's not just any vulnerabilities. If you go to the CVE website and you go and find any latest vulnerability over there and how to fix it, that doesn't mean your organization is vulnerable to that attack, you have to let your pen testers check it out. They have to analyze and find out the ones that applies to you. So it answers questions like, who is likely to attack us, and what's the business impact if they succeed? So when it comes to risk analysis, this is what they do to help them test their vulnerable infrastructure and also to prevent various attacks. Then when we move on to vulnerability assessment, so this uses software to scan system for known vulnerabilities. So it looks like for things like missing patches, open ports, or weaknesses in database. So patches here is out of date applications that are running on your laptop, your desktop, whatever system you're using, even your phone. The applications you're running, when they have a new update, when you go to Play Store or the iOS users, when you go there, you see that there is an update and you have to do it. Do not hesitate. Just go ahead and do it. Because if you don't, we have people who are specializing in mobile device hacking. Don't think attacks only happens to those using Windows systems and laptops. All your information, all your data nowadays are on your mobile devices. I mean, they are very portable to walk around with. Hardly will you find someone working with a laptop unless they are going to work or they have a meeting. Always, one device they never forget is their phone. If someone is sleeping right now and you're trying to steal their phone, they'll wake up for it because that's their life. So when you have applications that you need to update on your mobile devices, you need to do them. Do not take it for granted. Okay, so when we take the penetration testing, so this is an authorized simulated attack to test the strength of your security. So this is where you and I, or you are the management team. But for me, I am an ethical hacker, and this is where I comes in. So I will be granted permission by the organization. We call that a scope. Things that I have to do and things that I'm not supposed to do. So I will try to exploit the vulnerabilities to see how far they can get and what the potential impact would be. So I'll break into their system by them giving me, okay, you have access to this IP, this range of IP. You can conduct your pen testing on them. Then I'll go ahead and use my tools. I'm not going to use my eyes. Sorry, I'm going to use tools because tools automate better and they are really good. They help us to make tasks really easy and so fast. For you to spot, vulnerabilities on your system by reading the logs, by trying to analyze your processes, your daemons, it's really hard because especially when you open that task bar, it's not only one application that is running, multiple applications. So you'll be seeing them moving up and down and you'll be confused. So me, the pen tester or the ethical hacker, I have the tools to perform these activities. I hope we're good. Can we move on to the next slide? Okay. So our next slide is gonna be network vulnerability. It looks like I was moving too fast. Let me go back. Okay. Let me mention the tools that we use when it comes to performing these activities. So some examples of the activities and tools used for each of those. So when it comes to the risk analysis, someone might ask, what do they do? How do they do it? They use internal or external consultant and risk management framework, which we will go on. And also, when it comes to the vulnerability assessment, you are doing patch management, host scans, and port scanning. So some of the common tools that they use is OpenVAS, open source um, application. It's when you open your Kali or you run your Kali, this is an operating system we use for pen testing. You have this application there. Then we have Microsoft Baseline Analyzer. You have Nessus and a lot of them, because day in, day out, technology is advancing. So they find new tools that can perform much work better. So when it comes to pen testing too, you are using hacking techniques. This, we use both tools and techniques to breach defenses. So popular tools for this are Metasploit. If you've ever heard anybody mention Metasploit into your ears, this is a powerful tool. Then the core impact, or you might hire a professional ethical hacker to do this for you. I mean, you get there. This is not just the beginning for your cybersecurity journey. I mean, everyone here accept the fact that cybersecurity is lifelong learning. Learning doesn't stop. If I tell you that I still, if you are here and you are just thinking, okay, I need to get this certificate and I'm done now, there will be technology, especially with AI. We have people there that are working on as cybersecurity professionals. And gradually, all these positions that we have will be fading and new roles will have to come. And if you don't match up your skills to that level, nobody's going to hire you. Me, myself, I will not hire you. So you need to be constant learning. I have to tell you this. It's painful truth, but it is what it is. You cannot do anything about that. And I believe there are other fields in in the tech space that learning doesn't end there, it continues. So please, let's all prepare. So our next lesson or topic will be the Common Vulnerability Scoring System, CVSS. And I believe a lot of you are confused about this, but I will help you break things down for you to understand. So when it comes to the Common Vulnerability Scoring System, this is a scoring system. So what is the CVSS? Someone might ask me, and I'll tell you. If you know, I believe you add this knowledge to what you know. So it is a risk assessment. Remember, this is a tool designed to convey the attributes and severity of vulnerabilities. So all these vulnerability we've been talking about, they have classes. You cannot classify every vulnerability as a weakness in the system. We have stages from low to high or from low to critical. So something, we will get there, but something like from low to 3.9 is something that you can maybe ignore as an organization for the meantime. But 3.9 and above is something your organization must take action, a quick action. So let's move on. So as I said, this is a tool design. So it is an open vendor nature standard that weighs the risk of a vulnerability using several metrics. This combined to give a numeric score. So maybe 3.945, the number is going higher. So the risk involved in this vulnerability is getting higher as well. So this scoring system helps us to determine the urgency and priority for fixing it. So the benefits are clear. This provides standardized vulnerability scores. It's also open framework, so everyone knows what the metrics mean. It helps organizations prioritize risk in a way that it's meaningful to them. So the forum for incident response and security teams, which is the first, FIRST. This is capital. You can search them on your browsers and start to find out more information. So this is a custodian of CVSS. The latest version as we speak is 4.0, but in your slides, you have 3.1. So the 3.1 was released in June 2019. We are in 2025, and we have version 4 that is currently running. When you go to the website, you'll see all the previous versions that you don't have to worry about. I believe you'll be able to see those things there when you go to their website. So before we dive into the metrics, we need to know the term authority. Authority. We all heard the word authority before, especially when it comes to the government. We hear these words around the government. They've been using it, authority, authority. Can anyone here try and let us know what authority means? I'll be glad if someone could share with us what authority actually means when it comes to our profession, which is cybersecurity. Anybody? I know that Mr. Victor is around, but this time he has to rest. Let someone, we have one lady who spoke earlier. Can we have another lady in the room? Okay. Mr. Chris, you can go ahead. Since the ladies are not ready. Okay. Please go ahead. Tell us what you know about authority.
Okay, so from my understanding, authority is maybe a governing body that is responsible for enforcing maybe like cybersecurity standards or regulations.
You should research about this different techniques which
Okay.
every
Thank you. Thank you. Okay. He's not wrong. That was a nice way of explaining what authority means. You can also come up with your own. Tell us if you disagree to what he shared with us earlier. Let us know what you also think authority means when it comes to cybersecurity. Or you can mention, you can let us know the general meaning of authority. You don't have to stick to cybersecurity. Maybe that might be difficult for you. But if I make it easier by asking you to let us know what you understand when we use the term authority, I'll be glad. So anybody else to share with us what authority means? I think Mr. Chris, you can. Okay, thank you. Anybody else? All right. Since no one is ready, I guess I have to explain to the whole class. So authority in cybersecurity or in computing as a whole is an entity like an OS, a database, or a sandbox that grants and manages access and privileges. I will take it again. An authority is a computer entity like an OS, your operating system, a database, or a sandbox that grants and manages access and privileges. So we have this term that we call it basically an active directory. This is how we use to manage and give privileges to our employees, especially when you go to an organization, you realize that they have an admin that when all employees have an issue, they contact that person to come and configure it for them. So this active directory help the admin to control all the devices in that particular office. So this is an authority. The admin is the one in charge of it. He has to give access. He can give you access to your machine. He can decline you from using that machine, especially when you go to labs. Some machines you are not allowed to put or insert a drive. You ask yourself, how did they do it? So this was done by the admin. He has control of over all the computers in that particular lab, and he does that or controls that by using an active directory system. Okay, so let's move on and see. So as you can see in the diagram, I hope you can see it. It's too small. Let me try if I can zoom in. Can you see it? Or it's too small? Okay, if it is too small, I think when you go through that module, you'll be able to see them clearly. But for now, please, you have to pardon me for that. So as you can see in the diagram, we have the CVSS, which uses 3 groups of metrics to assess a vulnerability or to assess a vulnerability. So when we take those 3 groups, we have the basic metric group, we have the temporal metric group, then we have the environmental metric group. So when it comes to the basic metric group, this represents the characteristics of a vulnerability that are constant over time and across different organizations. It's broken down into exploitability metric and impact metrics. So me, an attacker, trying to gain access, we call that exploit. To gain access to a system, you have to do that by exploiting the system and also the impact that it causes, which are rooted in the CAI triad. We know the confidentiality, integrity, and availability. I believe each and everyone have learned this before they move on to this stage. So you understand what we mean by that. So when we move on to the temporal metric group, this measures the characteristics that change over time. For example, a new vulnerability might have a high score, but that score will decrease as patches and countermeasures are developed. So if you have that, don't think that the score will stay constantly. If you continue to do updates, your score will decrease. That will take you maybe from critical to let's say a medium. That will be how vulnerable you are to an attack. So when we move on to the environment, like the environmental metric group, this measures aspects of a vulnerability that are specific to an organization's environment. So this allows an organization to adjust the score based on what is most important to them. They have to do this based on things that are mostly important. There is this competition which we call um, I think we do pen testing or back bounty or back hunting. It's a hacking competition that normally runs on organizations. So hackers are given scope or guide for them to find vulnerabilities in companies' infrastructure or network, and then these hackers have to report their findings to organization. So if you submit a report and the score that you send to this organization is not anything that will cause much harm to them or something that is most important to them, you are not going to be paid for the bug you found in their system or the vulnerability. So this is one competition that happens mostly that I would like to share with you. So maybe you can go out and search bug hunting competitions that goes on, and you get more information on that as you evolve in your cybersecurity career. You don't necessarily have to wait for you to be employed. You can participate in some of these competitions to get paid by submitting a good vulnerabilities in organizations network. Make sure you follow the scope. Don't skip any, because that can cost you money too. So let's focus on the first group, which is the base metric group. So the base metric group has several exploitability criteria. You have the attack vector, you have the attack complexity, you have privileges required, you have user interaction, and the scope. So I will take this bit by bit for you to understand what we mean. So when we take the attack vector, this reflects the proximity of the attacker. The more remote the attacker can be, like over the network, the higher the severity. When we look at the attack complexity, it describes how many components beyond the attacker's control must be present for the exploit to work. When we look at privilege required, this captures the access level, like none, low, or high, that an attacker needs before. So this can be basically in the terms of numbers. When we are using numbers, we can have 0 as none, 1, 2, 3 upwards. I hope you get it. So that an attacker needs before they can exploit the vulnerability in our system. So when it comes to the user interaction, this asks, does a user have to do something like click a link for the exploit to be successful? And when it comes to the scope, this expresses whether the exploit can affect components beyond the initial vulnerable one. For example, can it break out of a sandbox? So basically, I believe this is the second time I'm mentioning this term sandbox. So sandbox is basically an environment where you test things. I hope you get it now before you do the actual thing on your system. So there are applications, when you hear the term doc, they are basically, or a Docker, they are basically applications that we download to perform attacks on them, to find vulnerabilities on these websites and applications before we do that on the actual system. So that is what a sandbox means. Okay, so we move on to the next slide, which is so basically this was the basic metric group. Then we continue with the tutorials. Was my slide showing when I was talking? Sorry for that. Please always let me know if my slides is showing, because I don't want to be moving without showing my slides to you guys. I mean, that's why I have it. Yeah. So this was what I explained earlier. Okay. Okay. So let's move on. Okay. So the other half of the base metric are the impact metric, which map directly to the CIA triad. I believe you can see that. Yeah. That is the confidentiality and the rest. So let's take it step by step. So when we talk about the confidentiality impact, this measures the impact on data confidentiality if the vulnerability is exploited. And when we look at the integrity impact, this measures the impact on the trustworthiness and authenticity of information. And when we talk about the availability impact, this also helps us to measure the impact on the accessibility of information and resources. So an attacker that consumes bandwidth or CPU cycles would impact availability. This is how they mostly do it. You might not see it because that is running in the background. So let's move on to the next slide, which is the CVSS process. So how do we use these? You can find the CVSS calculator on the platform that I mentioned earlier, which is the first.org website. So it's essentially a questionnaire. You make choices for each metric in the base group to describe the vulnerability. So as you make your choices, it generates a score. You can hover over each item to get a pop-up that will text explain what it means. So I don't know if you want me to go to the website, but I believe I'm only sharing. Someone is saying my audio is cracking. Please, am I audible?
Yes, you are, please.
Okay. Okay. I don't know. I am only sharing my slides, but let me try my best and find the website for you. So you are the first org. This is the calculator we're talking about. So as I was saying earlier, we have the various versions here currently. So if you want to get access to this, you have to come to first.org/CVSS/calculator, then the version. If you don't know the version, you just have to ignore the version aspect and you just have to move on. It will the current version. We have version 4.0, as I told you earlier, but what we were using was version 3.1. So we can go to 3.1 calculator, and this is what you see. When you go through your modules, this is the interface that you'll be seeing. But the current version have been upgraded. So this is what they were talking about. It's a questionnaire. So they'll ask you the attack vector. Is it a network? Is it adjacent, local? So after picking everything, then you get a score based on that. That is what our slides was trying to explain to us. I hope we are on the same page. So in case anybody wants to get access to the website, you just have to come to first.org/cvss/calculator. Then you come and pick the current the version according to your slides or your reading materials, which is version 3.1. But currently 4.0 is out, and this is how the interface looks like. Don't get scared when you see this the first time. Okay, so basically I would like to walk you through the process, how it works. So how does this work? As I was saying earlier, so it's essentially a questionnaire. You make choices. I've explained that to you. So after you complete the base metric group, the calculator displays a numeric severity rating like 3.8, which is low, which will be considered as low score you see here. So basically that is something, I don't know. Can you see my cursor? You see the yellow thing up there, which is 3.8, and we have low into bracket. So after the person did the questionnaire and everything, that was the score rating they had to tell them that this is how vulnerable you are. It is low. It is not medium. It is not critical. So an organization may consider this as something that is less important because it's low. Yes. But for you and I, please, it is, even if it is low, it is critical. We have to do justice to that. So it also creates a vector string, which is a text string that summarizes all of the choices you made. So the vector string makes it easy to share and compare assessment results. That is what it basically does for you to do. Now we will continue with the rating or how it works, the system. So it also creates so when you look at the table that you are seeing below on your screen, this table, what it does is basically shows the key for that vector string. For example, the AV you are seeing stand for attack vector, and its possible values are N, which is none. Then we have A, L, or P. So for network, adjacent, local, or physical, that is what those letters stands for. Then we have AC. As we know, AC is attack complexity. How complex is the attack? With L or H for low or high. So this string captures all the data in a compact, shareable format. As you can see, all these letters that we've discussed earlier, this helps you to analyze or to come to conclusion with that numbering or the scoring system. You will not see these numbers as the final ratings. It will be translated to the numeric scoring system for you to be able to understand what is going on in your system. So let's move on. Bye. So we have another table that you can see that is a continuation of the processes earlier, so don't get lost. So if we look at the vector string from the example, which is CVSS colon the 3.1, we have AV colon N slash AC. What this means is we can decode it using the table. So that example you can see over there, we can decode it by using the table. So AV colon N means attack vector is network. And AC colon L means attack complexity is low. Then we have the PR colon H, which means privileges required is high, and so on. So this gives us a full picture of the vulnerability characteristics. I hope we understand. Okay, so let's move on to the next slide, which is our 22nd slide. So we are also continuing with the processing. So we always remember that you must complete the basic metric group first. The temporal and the environmental metrics, then modify the base scores to provide an overall like adjusted scores. So this diagram that you are seeing over here is not just a diagram. It also means something. So we have the base metrics, which creates a base score. Then we have the temporal metrics. Adjust that can that's to create a temporally like adjusted score. So and finally, when we talk about the environmental metric, this also adjusts that to create the final environmentally adjusted score, which is specific to your organization. So this you need to follow the rule. So when you check the report, this table shows the qualitative ratings that correspond to numeric scores. So we have A scores of 0 is none. So basically that tells you that from 0.1 to 3.9 is low. Then from 4.0 to 6.9 is medium. From 7.0 to 8.9 is high. Then from 9.0 to 10.0 is considered as critical. That need immediate attention. So often a vendor will supply the base and temporal score. Your organization then completes the environmental group to tailor that score to your local net context. The final score that you obtain will guide you and your resource allocation. The higher the score, the more urgent the fix. So as you can see, critical is 9.0 to 10. So in general, any vulnerability that scores above 3.9, which I have said earlier, should be addressed. But for us, you and I, even if it's medium, you need to check it out. Don't say I have to wait for that to reach that specific qualification. So let me see.
Hello, Instructor Vincent. Are you still speaking? I can't hear you. Can anyone hear him? Walk.
No, I
No,
can't.
we can't hear him. He's out of the meeting.
Okay, please hold on. Let me reach out to him. Thank you.
Hello. Hello. Please.
Yes, I can hear you, sir.
Hello. Please, in Ghana, and I was using my router, so you can tell what happens when the light goes out. Router is off. So I was able to connect. I'm really sorry for this to happen. So since I only have some percent of battery left, I would like to take you through this as far as I can go. And if my battery runs down, then I think you can bear with me and do, because I think in this module we only have one lab and it's not something that is going to be intensive. So you just have to do the reading and do more research and do the project. So please pardon me for this incident. I hope you forgive me. Yeah. So let's continue. Are we all on the same page? Just let me know if we are all on the same page.
Please bring us back to the page.
Okay. So what we looked earlier before, I mean, my light went out, was the scoring system. So we are done with that. I believe everyone can see that. So our next slides will be the other vulnerability information sources. So basically, that is where we've got into. So if anyone is here and was lost during the session, please, this is where we are. So let's continue. I hope we're good. So the CVSS works together with other important information sources. So two key systems to know are the CVE and the NVD. So first, the CVE stands for Common Vulnerabilities and Exposure. That is what CVE stands for. I mean, the abbreviation that you see right there. Then what it actually stands for or means is a dictionary of common names for known vulnerabilities. So CVE identifier or a name. So this provides like a standard way to research it. I mean, if every CVE is just posted out there without a name, know it. So we have to give it a name. So if anyone is here that have ever come across a CVE, basically the naming system, which we will talk about, follows a certain standard. I mean, the year the particular CVE or the vulnerability. This is how it is done. So this, as I said earlier, so threat intelligence, service and security logs all use these CVE identifiers. So you can use them to find fixes. Basically, this is
Sir, please, we can't see your screen.
detail.
See your screen, sir.
Sorry. And I still have to do.
Yes, coming up. Thank you very much.
This is my screen now. I'm seeing my slide. Sorry. So we're talking about the the CV,
Yes.
SS, and the CVE. The common vulnerability scoring system works together with other two important information sources that you have to take note of, and two key systems that we have to know is the CVE and the NVD. So first, the common vulnerabilities and exposures, or CVE. So this is a dictionary of common names for known vulnerabilities. So each vulnerability gets a unique CVE identifier, so which provides like a standard way to research it. That is a way to make it easy for you and I to find it. So threat intelligence services and security logs, all of these people or all of these ways use this naming convention or identifiers. So you can use them to find fixes. The CVE like details website links these CVE records to their CVE scores. So when you find a particular common vulnerability exposures, they have the records and the scores. The scores will severity. All these things can be. I hope we get it. Okay, so let me see. Okay, so let's move on to the NVD. So when it comes to the second one, the first one was the CVE. The next one is the NVD. So the second system is the National Vulnerability Database. And the NVD is run by the US National Institute of Standards and Technology, which is NIST. You've heard this term over and over again. So it takes the CVE identifiers and adds more detail, like the CVSS scores, the technical details, and the resources for further investigation on a particular CV. Because have more information and resources on that. So basically, that is what the NIST system agency to your vulnerability system. So as we talked about earlier, we only have one lab in this module. So in that particular lab, you have to learn about the creators of a vulnerability assessment report and also review sessions of the report. And I believe if you are able to go through the content, it wouldn't be something that is hard or difficult. So as I said, this brings us to our lab for this session. So in that particular lab, you will get to review the features, only the features of an example vulnerability assessment report. So remember that you first learn, as I said, like section of that particular report. I hope we good. For someone who did not get what I said, I've repeated that twice, so I believe you all get it by now. So that brings us to our last topic, which is secure device management. And I believe it is really, really essential for you and I to know how to secure our devices or manage our devices. Can we all see my slides or can we all see it? Just give me a thumbs up if you can see that. I want to see a thumbs up. If we cannot, okay. Now, as you know, every time we move to a new topic, I pretend as if I don't know anything, and I want you to tell me what you know. Share what you know with us. So, just randomly, someone should share with us what they understand when we talk about risk management as a whole, like in general, apply to cybersecurity. To share with us what they understand by risk management, please be open to share knowledge with us. Anybody? Or you just want me to read for you? Today, Mr. Victor is on fire. Okay, Mr. Victor, please take us. Let's go. Sure.
Okay, so risk. When we're talking about risk, we're talking about the loss potential that exists. So anything that can cause losses, loss to an organization poses a risk. So how to manage such um, a risk? How to either reduce losses by um, the way uh, such such an item that poses the potential of loss, either through mitigation or substitution or other means. In that way, the risk is properly managed.
Okay. Okay. Thank you very much. Thank you very much. I think that was really so. Let's go by our cybersecurity definition of what risk means. I think he has done really well. Let's really appreciate him. So to start with the big picture in the room that we know, which is risk management. So this is the ongoing cyclical process of selecting and specifying security controls for an organization. As you can see from the diagram, the for me it's on my right hand, yeah, at the bottom, but I don't know how you see it. So from that diagram, it is like a continuous loop. Loop is something basically that goes over and over. So it's a cycle, like a cycle. So we say a cyclical process. So it starts with a risk assessment, which involves answering some of the key questions that we might ask is, who are the threat actors that want to attack us? What vulnerability can they how would a successful attack affect us? And what is the likelihood that these different attacks will actually occur? So these are some of the risk assessment questions we will be asking and the answers we'll be getting. I believe we understand what it means. So we move on to the next slide, and that talks about. So basically, this is a mandatory part of this assessment. So it's identifying threats and vulnerabilities, and then we match them together. So this is called basically we would call this a threat vulnerability pairing, TV. Yeah, someone hands it up. Julius, please kindly go on.
Okay, sir. Sir, please, thank you very much. We are not seeing your slide. We are only seeing this Germany.google. We are not seeing your slide. I don't know if that's what you meant. Yes, we can see your slide now. Thank you.
Oh,
Thank you very much.
what was I doing? Sorry, because I can see that my screen is sharing now. Is it much better? Can you
Yes,
still
it
see?
is. Yes, I can see your slide now.
Okay,
Thank
okay.
you.
My apologies.
Oh, it's off again. It's off again. The slide is off the screen again.
Wow. Please, for me. Uh, see what happened. Please, when you can see my screen, kindly let me know, okay? Because I don't know what is happening. But it's like my screen keeps on going. Um, please hold on for me. Okay, check it out. Um, please
Hello, I can't see it on my end yet, though my internet connection is lagging, so I wouldn't know if that is responsible for it.
hello.
So can someone else confirm if he or she can see the screen, please?
No, I'm not seeing it for myself.
Hello, class. Okay.
Yeah, hello. It's
Hello,
not.
Inspector Vincent. I can hear you, but I cannot see your screen.
I don't know if it is my network, but yeah, because I can see telling me that at the moment. I don't know what's wrong. Yeah. When I was trying to get content, I don't know.
Okay, it might be the network. So, let's just keep on with the class. Why
From
you
me,
try
let
sharing?
you can share.
My internet connection is lagging seriously. So I had to
Hello.
connect through the phone. Hello, can you hear?
I think I don't know. Okay.
You can
Yes.
just
Yes. I.
continue with the explanation while you keep on trying to share the screen. I guess it's
Yeah.
the network.
Class, please, can you hear me?
Yes, I can hear you.
Yes, we can hear you, Mr. Victor.
I guess your connection is lagging too.
Okay. Okay. We got to the risk. We got to where we were facing. So basically, that's all. Oh, pardon me. At the light is still not in into hotspot from her phone. I don't know. The lights will be back, but I hope we for now. Am I audible? Can you guys hear me?
Yes,
Am
you
I
are
still lagging?
audible with intermittent break.
Yes, you are audible, Mr. Vincent. You are very, very audible. We can hear you.
Please, am I still lagging?
It's better now.
Okay, let me rejoin the meeting again. Okay, okay. Thank you for confirmation. Sally, just to have a question, or is to up? Okay. So if there is no question, then let's continue. So we were saying that the risk management is a mandate, like a mandatory part of this assessment. So it's, I mean, the most important part of it is identifying threats and vulnerabilities, and then we match them. So we call this as vulnerability and peer equity. So this is the baseline of, I mean, your intranet, like your intranet risk. So that is your risk before you implement any key controls. So you can then compare this baseline to future assessments to see, I mean, how effective your risk management is. So once the risks are identified, we can then score or them to prioritize our response. For example, maybe a vulnerability that maps to multiple threats will get, I mean, a higher rating. So this is something we can also check it out. So once we've identified a weight risk, there are 4 potential ways we can respond. And these potential ways are risk avoidance, risk reduction, sharing, and risk retention. So the avoidance, this means you simply stop performing the activity that creates that particular risk. So if the risk overweights the benefit, you just don't do it. And also, if when it comes to the risk reduction, this is what we typically think of, as security. So you take measures to reduce the vulnerability, like implementing security controls. And when it comes to risk sharing, this means shifting some of, the risk to another party. So a common example is buying cybersecurity insurance or outsourcing your security monitoring to a security as a service provider. So those of us that know Amazon, this is something kind of related. You've used their platform or their services, you know how it works, like doing things in the cloud. So this is something they were talking about, or it's a suggestion. And also when it comes to the risk retention, this typically means you will formally accept the risk and its consequence. So this is an acceptable strategy for low impact risk where the cost to fix is just too high. And if you can, as we said earlier, try your possible best to avoid this risk or retention to reduce your price or the cost that might be involved. So let's vulnerability management. The first one was risk management. Now we are moving to vulnerability management. So according to NIST, which is NIST, this is security practice designed for every organization that you can think of that have access to computers and use network. So it's typically designed to protectively prevent the exploitation of IT vulnerabilities. So the goal is to reduce the time and the money spent dealing with breaches. It's always better to proactively manage vulnerabilities than to respond after an exploitation has already occurred. So it is this particular framework by NIST is something good, or the ways of meeting some of the vulnerabilities is something helpful to avoid the loss or the cost of an organization spending more money. So it requires a robust system for identifying new vulnerability from vendor bulletins and source like the CVE. So this is what NIST typically helps you to do. So security professionals have to be skilled at assessing the impact of a new vulnerability on their organization and then testing the implementation, like the implementing the solution. So as I said earlier, you don't just have to learn cybersecurity for certification's sake. You need to prove that you have the skills because to be able to detect new vulnerabilities, you need to understand what you're doing. If you don't understand what you are doing and you are following a cheat sheet, I bet you are not going to go anywhere. You just be at the on the surface. You wouldn't be able to find vulnerabilities because if you were used to a vulnerability that everybody know, the moment you spot new ones, you might be confused. You will not know what it means. But if you are good at what you do, you'll be able to spot this. So vulnerability management is a life cycle, just like risk management. And we discussed the risk management cycle earlier. So as you can see in the diagram, sorry you cannot see my slide, but when you go to your reading materials, you'll be able to see that it has 6 steps. We have the discovery, we have the prioritized assets, we have access, we have reports, the remediate, and verify. So these are the 6 steps when it comes to vulnerability management. So let's walk through those steps. It's just quite unfortunate that you cannot see the screen that you can follow along. So when it comes to discovery, this is where you inventory all assets on your network to find vulnerability. And then we move on to prioritizing assets. So you can't protect everything equally. Here, you can categorize assets and assign a business value based on their criticality. This is what you can do. You cannot do everything. You cannot protect everything. So assets. So you determine your risk profile based on assets, criticality, the vulnerability, and the threat. Then we move on to report. So you can measure and document the level of business risk. Then remediate. This is the fix. Whenever you hear the word remediate, that is basically fixing those vulnerabilities. So you prioritize the fixes based on business risk and address the worst ones first, which is in this case the critical aspect, which is from 9.0 to 10.0. That is the first on the map. That is the highest vulnerability that you need to consider. But as I always say, like, you need to check out for everything to avoid any future losses. So now let's move on to asset management, which is a huge part of that life cycle or the life cycle. And you can't protect what you don't know you have. So basically, hello, Hassan.
Sorry, sir.
Okay, that's fine. So I was saying that a huge part of that life cycle is the asset management. So you can protect what you don't know and what you don't have. So asset management involves implementing systems that track the location and configuration of all networked devices and software. So this only tracks corporate assets, but can also be used to identify unauthorized devices on the network. So NIST described this as an ongoing process. It's something that it's not a one-day stop. So you cover aspects of this, you compare it to the desired state defined in your security plan. Then you identify any non-compliant assets. And also, last but not least, you then remediate them, accept the risk, or update your policies. Then you repeat this process over and over again until maybe your organization no longer functions. But as long as you keep on running, making money, you also need to, go through these processes each and every time. You can be on maybe based on your business plans, monthly, 3 months, yeah. But I would advise you, it shouldn't be more than 3 months. So we are continuing with asset management. So the figure, which you are not seeing right now, but when you go to your slide, you will be able to see that. It will give you a simple overview of that process. So you collect the current state of all authorized devices and specify the desired state of devices. And also you compare them to find discrepancies in devices state. Then you correct this and accept risk or update policies. And the loop continues. So it's something that will happen over and over again. Now, from management, we move on to mobile device management. That is what I said earlier. Now, everybody carries their device around with them, and something that is portable. Even a 12-year-old boy or girl, you see them working with phones because that is their, it's like their life depends on. Without the internet, our life will be boring. I don't know how boring it will be, but that is what we've made it look like. So now, mobile device management, how do we manage it? So asset management gets really challenging with mobile device management or MDM, so mobile device management, especially in the age of bring your own device, BYOD, bring your own device. So you can't physically control these devices and be lost, stolen, or tampered with. Putting your data and network at risk. Your mobile device management plan must include steps for when a device is lost. So basically, if you ever use Google or Find My Location on your devices, typically on Android phones, if you switch that particular permission on and your phone gets stolen, and hopefully they don't turn it off, and you try to find it with another device, it will pinpoint where that particular device is being located. And I believe most of us have used that before. I tried using that once, but I didn't find. They turned it off, so I was not lucky. But I hope in the future we have more, secure ways of finding our devices when they get stolen by, our colleagues who don't want to work for their own. Okay, so we continue. So network admins should, assume all mobile devices are untrusted until they have been, secured. So mobile device management systems like the Cisco Meraki System Manager shows here in the figure. When you try to go through your slides, you see all these things. Allow security teams to configure, monitor, and update all these diverse mobile clients from the cloud. So in your, you see a closer look at the Meraki dashboard. You can see the user, the device type, the location, and net one central console. This is something that will help you to be able to understand what is going on in your system. So when we move on to configuration and management, related to asset management is configuration management. So this addresses the inventory and control of the hardware and software configuration on your system. Secure configurations reduce risk. Keep that in mind. So a typical example that I'll give you is if your organization has thousands of laptops, each one is part of the attack surface. To manage this, you can create a baseline software images and hardware configuration. So the image include all required software, endpoint security tools, and custom security policies that will help you to prevent users from changing settings that could make the system vulnerable. So that is something that you can do. And that is one typical example. And so configuration management also extends to your networking device and service. As NIST define it, or the NIST defines it, it's a collection of activities focused on establishing and maintaining the integrity of products and systems. So this has become especially challenging with cloud data centers and virtualization. So to manage this at scale, we use tools like Puppet, Chef, Ansible, and SaltStack, which enable efficient management of thousands of servers. When you go to the data centers, there are a lot of servers. You can't handle them with, manually. You have to do that with scripts, which is automation. And these are some of the tools you can use to do that. So now we move on to enterprise patching management. So now let's talk about enterprise patch management. So this is closely related to vulnerability management. Vulnerability pops up all the time in operating systems and firmware. So patch management is the entire process, of identifying, acquiring, distributing, installing, and verifying that a patch is, installed on a required system. So to be honest with you, installing patches is frequently the single most effective way to mitigate software vulnerabilities. There is no other effective way to do that than this. And this also required by compliance regulations like the SOX, the HIPAA. Failure to patch can result in audit failures and penalties. So you need to take this into consideration. And this process relies heavily on asset management data to know which system needs the patch. So a Windows pop-up will come that tells you that you need to update this particular software, like your firewall or an audio something or drivers. These patches that pops up tells you that you need to do the patch or update, and you have to do it. Don't ignore it. Okay. So as I said, enterprise level tools. Some of these enterprise level tools that you can use is SolarWinds or SCCM. So these are used to automate these particular tasks. It helps you work faster. So one example that I can give you of a patch management dashboard from SolarWinds, it is basically in your slides. When you get there, you see it. It gives you a summary of nodes managed, desktop, health, and even the top 10 patches missing in your environment. So there are techniques for patch management. And these techniques, one of it is called the agent base. So this requires a small piece of software, an agent. So right now, in the age of AI, we have something we call agents. So agents typically help you to perform a specific task. So that is what we are trying to see or talk about here. They are piece of software that helps you to complete a task. So this agent will be running on each host. That agent will report its status back to a central patch management server. So it also determines if it needs patches and then install them. So this is where the automation is taking place. After every command, there is a command that follows. So that is automation. So this is the preferred method for mobile devices, since the agent can check in even when the device is off the corporate network. So the age of AI, I love to use that example a lot, because first it was chatbots, but right now we've moved to agent bases that helps us to do tasks. And these agents, I believe in the next 4 years or so, they will be more powerful that we have to sit behind for them to do everything, because the data we feed them helps them to do much better. So this is the whole idea of automation. Some tasks that are complex, really complex, can be done with this. So simple. So the second techniques, apart from the agent base is agentless scanning. So here, the patch management server scans the network for devices. It remotely determines what patches are needed and pushes them out to the clients. So the clients will be doing that. It's not the computer. It will push it to you to confirm whether you want to do it. So the advantage you have to maintain an agent on every machine. The disadvantage is, that you can only patch devices that are on the scan network at the time of, your scan, which is problem for mobile devices. Those of you that have rooted your device, you realize that you don't have that advantage of get the current security update because you've decided that you want to have control of your mobile device, and you have control over your mobile device, but you don't have the current updates or patches. I am a victim of that. And mind you, I don't use my phone for just anything. I have rooted for doing that. Therefore, I don't click on malicious links. I don't just visit any website or any application because I know what I'm doing and I don't want to be a victim. Okay, so the third technique, remember we talk about 3 techniques with some techniques, and the third one is passive network monitoring. So in this approach, devices are identified by monitoring traffic on the network, which one is the server just listens to the traffic and tries to identify software versions from the data flowing by. So this is only effective for software that actually includes its version information in the traffic. So it's not like a complete solution. It helps you to a certain level. Are we good? Are we on the same page, or am I moving too fast?
No, we are good. We are good. I'm good.
Ah, okay. The, I mean, this will help to do things or prevent to get access to the system only if you follow the NIST guide or framework. If you don't take things for granted, that is when this help you. And I believe by now each and everyone is open to do the right thing. So if wherever you find yourself, any corporation, any organization that you find yourself associate with, if you realize they are doing things that will put into a high risk of being attacked, you are an employee of a particular organization. Don't just be looking at them for them, affected. You can, your channel of communication. You can just alert them. It's better than you sitting be there and that thing will happen before you will be if I had known earlier, I've given the information out. Please don't let it be late. Be part of that organization. Help the organization grow. You have the knowledge. And even not only in organizations or your workplace, among yourself, your friends that comes around. Not everybody have the knowledge or knows what is going on in the tech space when it comes to this internet stuff. So they might be doing something that they think is in their favor, but you will know that that is something dangerous. So please open your eyes. Don't just do anything anyhow. So basically, that's wrap up our final session. So let's quickly summarize what we've learned in this module, so that those of you that were not able to follow up or catch up will get an idea of what we talked about today or this module. So what did we learn? And I would like to do this by opening the space for each and everyone. I mean, I know my time is up here, 9, and I'm spending 9:30. It's almost 9. So because time is up, I wouldn't like to waste us quick through what we've learned earlier. So for those of you that didn't get it with learn. So first we learned that network device profiling is crucial for creating a statistical baseline of normal performance. So a server profile establish the accepted parameters for like a specific server. And also we learned that we can use big data analytics to perform anomaly detection. We also cover the 3 types of network security evaluation, which is risk analysis, vulnerability assessment, and penetration testing. So if any of us here and looking in the future to dive into any of this specialized area, just go for it. Make sure you master the skills, not just the certifications. And we also we then did like a deep dive into the common vulnerability scoring system, where we also had to check out the CVE and NVD. Yeah. So when you go to the website of the first.org, you'll be able to use the system to score. So which is that was an open source, something industry standard for rating and prioritizing vulnerabilities. So we saw that it uses the 3 metric group, the base, temporal, and the environmental. And also we learned that the CVSS calculator gives us like a score from 0 to 10, and then so basically the higher the rating, more urgent the need for remediation or mitigation. So that is some of the things we covered, and we also went ahead to cover the risk management, including the 4 ways to respond to risk. And these are the avoidance, reduction, sharing, and retention. We define the 6 steps vulnerability management life cycles. That is discovery, prioritize, assesses, reports, remediates, and we then verify. We also saw that the asset management and the mobile device management are key to knowing what's on your network. We also covered configuration management, which controls the hardware and software configuration of system. And finally, we discuss patch management, which is security updates, especially those of us that use Windows. It is quite easy for you to get to know that. But if you are using a Linux system, I think you have to run a command, which is the sudo apt update, sudo apt upgrade. If you are on Linux, that is what you have to do to see the available updates or patches you have to do. But for Windows, when you go to the update center, you find all these things. So the process of acquiring, distributing, and verifying patches, and we also look at the agent based, agentless, and passive monitoring techniques. So this is what we've done so far. So I believe this was helpful to each and everyone here. Thank you for having me tonight, and I hope you've learned a lot. Bless you. If there is any question, I think we have any question you like. Thank you, everyone.
Thank you so much, Instructor Vincent. Despite the uncooperative network. Thank you. We sincerely appreciate. Please let's appreciate him. Let's appreciate him. Let's appreciate him. And if you an appropriate time to your question. Have 2 minutes to do that. Any questions, please?
Okay, Mr. Victor.
We don't have any. Okay.
Victor hands is up, so I think he has a question. Okay.
Okay, so I dropped one question in the comments section when you made reference to the current CSS version, that the latest, the latest version is 4.0, but what we have course material is 3.1 as the version way. So if the question comes up during exam, perhaps the question on the latest version, what do we go with? Is it I don't know whether such a question can come up, but I'm just thinking that maybe can happen. If it comes up, which of the version will the scoring system most likely go with? Is it the latest version, the actual latest version, or the latest version in the course material?
Okay, thank you for your question. And I think mostly the case is that the concept is still the same. It's just an upgrade of the interface and some few touches of how things are categorized. So if you are able to understand what version 3 point, remember version 3.1 wasn't the only version before. There were version 3.0, 2.9, and below. So it all follows the same concept. The moment you understand the concept behind everything, the rest will be easy for you. Thank you. I hope your question is answered. Was that okay for you?
Yeah, I think I'm satisfied with that. So hopefully, the exam will not throw up any question.
No, don't worry. Because they did mention the particular version you're using, there will be no question that will come, ahead of you. But it's always good for you to be on the safer side. You add that to your knowledge, and that will help you. Because if you can remember, I told you in the beginning that in cybersecurity, we never stop learning, even though it's the same technology, but the techniques change. How we go around things change, and you need to update yourself with this data. So this is one of the cases where versions of platforms that we use change, though it's based on the same concept, but there might be few changes. That is, how the interface look, how things are arranged, or an addition. I hope you're good. All right. Thank you. And thank you for your contribution for tonight's session. Anybody else?
I'm not seeing any hand up again. So I want to assume that there are no other questions. And in view of this, we'll be calling it a night. Thank you very much. And thanks to everyone that attended this section tonight. The session was informative and educative. Thank you once again, Instructor Vincent. And on these notes, I say bye to everyone and have a lovely night rest for those of us in the night session. Bye.
Okay, bye. Thank you, everybody. Enjoy the rest of the night.
Thank you. Good night to you too.